Hello guys. Yes, I just want to bring your attention back to naming. I just want to do some quick revision with you on naming. I know we have done it, but I just want us to remind ourselves of the few details. So naming. In naming, let us start with ionic compounds. Ionic compounds. So, so how will you know this is an ionic compound? It simply means it's between a metal plus a non-metal. And how will you name a non-metal and metal? So it's simple. You just have to follow this pattern. This is how to name. Please, these are the short notes you need at this juncture. So you just start with the metal name. Then you add the non-metal stem. The non-metal stem. And then with the suffix ide. So this is the pattern you should follow whenever you want to name a metal and a non-metal. For example, the common one. So how will you name this one? So we're going to start with the name of the metal. And what is the metal here? Our metal in this compound is sodium, right? So we're going to write sodium. And then we need to write the non-metal stem, so which is chlor. So it's chloro. And then since it's chlorine, so we're going to say chloride. We add IDE, so it's sodium chloride. I hope this one everybody knows it. So I want to move quickly. For example, also similarly, let's say maybe we want to name this ionic compound, right? How will you name this one? We start with the metal name. The metal name is calcium, and then you add the non-metal stem plus IDE, and then it becomes calcium bromide. So that's basically it about ionic compound. So now, by the way, if you notice something here, ionic compounds are, I think I forgot to tell you, this is how to name ionic compounds when the metals have a fixed charge. This only applies, I think, NB only applies when the metals have a fixed charge. Please, this is very key. This is very key. Okay, by the way, if maybe you don't get what I'm saying when I say only applies when the metals have a fixed charge, just note that if the metal is not a transition metal, this is how to name. But then you know that if it's an ionic compound, that involves a transition metal. So let's move on. That involves a transition metal. Transition metal. This is the pattern to follow. So should also take notes here. Another thing to note with transition metals is that we use Roman numerals. Right? To indicate, we use Roman numerals only to indicate the metal oxidation state, right? The Roman numerals, you know them. It's just you know them. Yeah, I mean these ones. So then let's dive in. So how will you name it? You will start. How will you name it? Let me say name, and then you start with the metal, right? And then here you put the oxidation state. the oxidation state in Roman numerals. I'll just write Roman nu. Hope you're getting. I'm trying to manage my space. And then that's when you add the non-metal stem plus IDE. So basically it's just still the same, because since it's still an ionic compound, we are still going to name the metal and then plus the non-metal stem and then plus the suffix IDE. But then since it's a transition metal, and transition metals they don't have a consistent charge due to their oxidation state, so you have to write the metal and then you include the Roman numerals indicating the oxidation state. For example, if you have these two compounds and you have to name them, if you have these two compounds, right, you can see that not 3 here, sorry, 3 here. So you see, how will you name this? Now the first thing that you will notice, okay, this is an ionic compound, but then it involves a transition metal. That means I should at least find the oxidation state of this guy here, right? So that means how or maybe the charge, yeah, it's just still the same thing. So how will I name this? So I'll start by naming the metal. The metal is ion, right? And then Roman figure 2, and that's when I add chloride. This is very simple. You just have to notice whether you are dealing with a transition metal or not. Then this one will be ion 3 chloride. The reason why I'm not explaining too much is because I believe we did this at class, so which I'm just reminding you or trying to revise with you. Yes, moving on to our naming. So we have just did ionic compound. Now ionic compounds with polyatomic ions. Now let us do ionic compounds with polyatomic ions. Now for this one, I will always tell you the truth. You see, for this one you won't survive if you don't know your polyatomic ions. So I'll advise you you should know the common polyatomic ions. For example, the most commonly atomic ions that everybody should know. I will not mention all of them here, but I remember at class I wrote them all on the board. Those ones are must know. These are must know for it. Atomic ions, maybe NH4. You know, this is ammonium. Oh, that's the hydroxide. Then if you recall, this is the carbonate. And then you know this is the sulfate. So these are some of the few polyatomic ions that you should know. Now, how, maybe for example, to name an ionic compound with a polyatomic ion, it's very simple. For example, you'll find a question sort of maybe it's just sodium, then we attach it to SO4. So how will you name this? You will simply say sodium, the metal, and then you put the name of the polyatomic ion, just like that. That's why it's key to know the polyatomic ions, because to name a metal attached to a polyatomic ion, you don't follow many things or like rules or stuff like that. You just have to name the metal and then followed by the name of the polyatomic ion. So you will find that, for example, you will find a question like this. You see, so how will you name this? You know, this is your metal, so it's calcium. You just simply say calcium, and then what's the name of this polyatomic ion? Hydroxide. And then you just put hydroxide. So it's basically that simple when you know the polyatomic ion. So this one I must know. So I always advise students to try and know all of them that the lecture has provided. You should know them. So that's basically it about naming ionic compounds with polyatomic ions. So yeah, Now moving on, also this is revision, that's why it's like I'm in a hurry and I know that we have done this. Now covalent, naming covalent or molecular compounds, that means a non-metal plus a non-metal. So how will you name a compound that between a non-metal and a non-metal? When you name non-metals, compounds of non-metals, both non-metal, we use prefixes. Now we use prefixes. Please keep this in mind. Whenever you see a non-metal, or you see a molecular compound or a covalent compound, we use prefixes. For example, we use prefixes like mono, that means one. Prefixes like di, that means two. Prefixes like tri, that means three. So, and so on and so on. Now, for example, or tetra, 4, penta, 5. For example, so how will you name? For example, you will be having two elements. For the first element, right? How will you name? You say prefix. Please take this phone, you should know. Prefix, we put prefix only if it is greater than 1. For example, okay, I will give you an example. Let me finish here first. And then for the second element, you add prefix, and then you don't stop there, you add IDE. For example, we both know that this is carbon dioxide. What I'm saying when I say for the first element, we only put the prefix if this carbon, maybe you have twice of them. That's when we can say dicarbon. That's why in most cases you can't write monocarbon di for 2 oxide. We just say carbon dioxide. So this is what I'm trying to clarify here when I say for the first element just put the prefix only if it's greater than 1. Then for the second element you put the prefix and then plus IDE. For example, how will you name this element? N2O5. Oh my bad, O5. So you can see that the first element, which is nitrogen, is greater than 1. So what will you, how will I mention? Since it's 2, I'll say di nitrogen, and then second element prefix pent oxide, then IDE. So that's basically it about molecular compounds or covalent compound. These are very easy stuff, so just make sure you do enough questions, and also don't forget to know your polyatomic ions. Now let's move on. Now how will you name acids? Now let's move on to acids. Now acids, for acids we have I will just do something like this. For acids we have something we call binary acids, right? And how will you know this is a binary acid? A binary acid is simply an acid that is H plus a non-metal, a non-metal. So how will you name a binary acid? So this is how we will say. Now we name a binary acid following this. So we start by hydro because of that H, and then you add the stem, right, of whatever non-metal is there, and then you plus ike, right, and then plus acid at the end. So this one also you should keep it in your head or in your short notes. So this is how to name a binary acid. It's hydrogen, then the stem of the non-metal, then ike plus acid. For example, common acid. Oh, come on, man. Not now. Where am I notes? Okay, thank you. They're here. Yes. Where were we? We were just around acids. Don't know why my phone is busy. So common acids, HCl. Sorry for the delay, HCl. So how will you name this? Since we can see that this is the H and then this is the nonmetal, so we know that this is a binary acid, so I should follow this. So I start by simply saying hydro, right? And then the stem of the nonmetal plus ic, and then that's chloric, right? So that's chloric. Then I add acid at the end. How easy was that? Now, it's very easy because I know what I'm naming. Sometimes naming becomes difficult because you don't know what you are naming. If you don't know that what you are naming is a binary acid, you are in danger because you don't have more like the template. If you don't know that what you are naming is an anion compound with a transition metal, that means you don't know the template. So you'll be doing guesswork. That's why it's very critical to really know what you are naming specifically. For example, how will you name this one? HBr, very common acid, this one. So also I can see that this is a binary acid. So how will I name this? I start by hydro, and then the stem of the nonmetal, and then brom, then ic, and that's acid. Yeah, so that's it. I'm done with binary acid. So we're moving. I'm just reminding you this. We did them co-classic. Now, then in acids also we have something we call oxy acids, right? So how will you notice that this is an oxy acid? An oxy acid H plus polyatomic ion. You see, polyatomic ions, they are back again. So for this one, to name oxy acids, if you don't know polyatomic ions, you are cooked, my friend. Yes, you are cooked. That's because these ones are very simple. Also, simple in a way that let's say you have a polyatomic ion that ends with 8. You know, polyatomic ions, they hinge around 8 somewhere there. Now, if you have a polyatomic ion that ends with ATE or 8, it means that's an ic acid, right? Keep this in mind. And also, if you have an acid that ends with ITE, it means it's an OS acid. So also, how this information is very useless if you don't know polyatomic ions. Believe you me, because if you don't know whether the name of the polyatomic ions, let's say maybe you can't differentiate between sulfate and sulfite, that means you'll be cooked, because look at our pattern, look at our template, how we name oxy acids. If it's 8, it's ic acid. If it's 8, it's OS acid. Then maybe you swap between sulfate and sulfite polyatomic ions. That means you are cooked. For example, I'll give you an example. How will you name HNO3? And how will you name HNO2? And how will you name H2SO4? Right? How will you name this one? Now, you can see that for me, the first thing that I've noticed here is that for this one, I can see my nitrate, right? So once I see my nitrate, I see ATE. So that means this is an ic acid. So how will I name it? Very simple, nitric acid. How easy was that? It was easy because I know what I'm naming, right? Now, okay, how will you name this one? HNO2. Now, I can see that this is a nitrite. That means it's an ITE. So that means this will become a nitrous acid. And then also, lastly, I can see that this is a sulfate. So if it's a sulfate, I know it's an ic acid. So that means this will be sulfuric acid. This one is very common, sulfuric acid. So once again, I repeat, naming can be easy. You just have to know what you are naming. Also,